Hello everybody, welcome to Soil Mechanics online course. Today I'm gonna talk about the physical states of soil. The behavior of a soil depends not only on the property of individual constituents of the soil mass, but also on those properties due to arrangements of the particles in the soil mass. For example, we can vibrate the sand to transform it from a loose state to a dense state. For coarse-grained soil, that is more than 50% of the soil is larger than 75 micrometers. We use the terms loose and dense to describe its physical states. Technically, we use relative density to describe the looseness or denseness of coarse-grained soils. For fine-grained soils, that is more than 50% of the soil is finer than 75 micrometers. We use the term consistency to describe its physical states. Consistency is described by such terms as hard, stiff, plastic, and soft. The term relative density is commonly used to indicate the in situ denseness or looseness of coarse-grained soil. It is defined as Emax minus E over Emax minus Emin, in which dr is the relative density, E is the in situ void ratio of the soil. Emax is the void ratio of the soil in the loosest state. Emin is the void ratio of soil in the densest state. Engineers qualitatively describe the coarse-grained soils according to their relative density, as presented in the table. The relative density corrects very well with the strengths of coarse-grained soils, denser soils being stronger than looser soils. For a fine-grained soil, its physical states can be depicted by its consistency. Consistency of fine-grained soils refers to the degree of adhesion between soil particles and to the resistance against forces that tend to deform or rupture the soil aggregate. The physical and mechanical behavior of fine-grained soils is linked to four distinct states: solid, semi-solid, plastic, and liquid, in order of increasing water content. Let's consider a soil initially in a liquid state, and it is allowed to dry uniformly. If we plot a diagram of volume versus water content as presented in this figure, we can locate the original liquid state as point A. As the soil dries, its water content reduces and its volume becomes smaller. At point B, the soil becomes so stiff that it can no longer flow like a liquid. The boundary water content at point B is called the liquid limit. It is denoted by LL. As the soil continues to dry, there is a range of water content at which the soil can be molded into any desired shape without rupture. The soil at this state exhibits plastic behavior, the ability to deform continuously without rupture. But if drying continues, the soil becomes a semi-solid. Now, the soil cannot be molded without cracking. The water content at which the soil changes from a plastic to a semi-solid is called plastic limit, denoted by PL. As the soil continues to dry, it comes to a final state called the solid state. At this state, no further volume change occurs. The water content at which the soil changed from a semi-solid to a solid is called the shrinkage limit, denoted by SL. The liquid and plastic limits are also called the Atterberg limits. The range of water contents over which the soil deforms plastically is named plasticity index. Pi. It is defined as the differences between liquid limit and plastic limit. The plasticity index is important in classifying fine-grained soils. It is fundamental to the plasticity chart, which is the basis for the unified soil classification system. We will talk about it later. Since engineers are interested in the strengths and deformation of materials, we can link specific strengths, properties with each of the soil states. A measure of soil strength using the attribute limits is known as the liquidity index, Li, and it is defined as Li equals to in situ water content W minus plastic limit over plasticity index Pi. The plasticity of soil is caused by the absorbed water that surrounds the clay particles. In another word, plasticity comes from the clay minerals presenting in the soil. So, we can expect that the type of clay minerals and their amounts in a soil will affect its consistency. People defined a term called activity to describe the importance of the clay fraction on the plasticity index. Activity A is defined as the plasticity index over the percentage finer than 2 micrometers by weight in the soil. Activity is used as an index for identifying the swelling potential of clay. Well, that's all for today. Thank you for your attention. See you next time.